Welcome back. The objective of this video is to solve trigonometric equations using the sum and difference formulas and double angle formulas that we've introduced. So here in sample 13, it says find the solution of the equation in the interval between 0 and 2 pi. Verify with the graphing utility. We may or may not do that. So we've got the sine of x plus pi over 3 plus the sine of x minus pi over 3 equals 1. So what we've got on the left here is a sum formula plus a difference formula equals 1. And I know, because I know the answer here, we're going to have to also apply our even and odd identities for sine and cosine. So keep in mind that the sine of the opposite of x equals the opposite of sine of x, and cosine of negative x equals the cosine of x. So let's go ahead and put everything into our sum formula and our difference formula and set it equal to 1. So our sum formula says that the sine of x times the cosine of pi over 3 plus cosine of x times the sine of pi over 3. That's our sum formula, the first part here. And then the second part plus now our difference formula, the sine of x cosine of negative pi over 3 plus the cosine of x sine of negative pi over 3 all equals 1. Well, we would like all of these angles to be pi over 3, but we've got some of them are positive pi over 3 and some of them are negative pi over 3. So if we look at our difference formulas, we can see that the cosine of negative pi over 3 equals the cosine of x, or the cosine of pi over 3. So we can rewrite the cosine of negative pi over 3 as the cosine of pi over 3. And then this sine of negative pi over 3, so the sine of negative x, equals the opposite of the sine of x, which would then make this minus the cosine of x sine of pi over 3. That's all equal to 1. So I'll show you what that looks like. So all I've done is really rewrite most of this, except this middle step here. Now we have the sine of x cosine of pi over 3, and we have negative cosine of x sine of pi over 3, all equals 1. Well, adding and subtracting, these two that are crossed out, they cancel each other out. So now we're left with sine of x cosine of pi over 3 plus sine of x cosine of pi over 3, which I think that's just 2 sine of x cosine of pi over 3. And indeed it is. Well, I know the cosine of pi over 3 from my unit circle, so that's on my unit circle. I have 2 sine of x. The cosine of pi over 3 is 1/2, and that is equal to 1. 2 times 1/2 is 1, and I'm left with the sine of x equals 1. So x then is equal to the arcsine of 1. So where is sine equal to 1 on my unit circle but at pi over 2? So x is equal to pi over 2. So I get x is equal to pi over 2, which is the same as 3 pi over 6. Now in this next step, all I'm doing is substituting x into my original function, and I get sine of 3 pi over 6 plus 2 pi over 6, which is the sine of 5 pi over 6, plus the sine of 3 pi over 6 minus 2 pi over 6, which is pi over 6. And does that equal 1? Well, the sine of 5 pi over 6 is 1/2, plus 1/2 equals 1. So that does indeed check out. So x is equal to pi over 2. Example 14 says find the solution between 0 and 2 pi. Now I have the sine of 2x, so I have a double angle on the sine of 2x. So I'm going to use my double angle formula, and I'm going to rewrite that as 2 sine of x cosine of x, and then plus my cosine of x equals 0. I have a common factor of cosine of x, so I'm going to factor that out. So if I factor out the cosine of x, I'm left with 2 sine of x plus 1 equals 0. And now I have these two factors. I can set each of them equal to 0. So the cosine of x equals 0, and 2 sine of x plus 1 is equal to 0. And I'm going to do the arc cosine. So where is the cosine equal to 0, but x is equal to pi over 2 and 3 pi over 2, right, at these locations on my unit circle. And on this one, I'm going to get 2 sine of x equals -1, or sine of x equals -1/2. So this is going to be some version of pi over 6. Sine is negative in the third and fourth quadrant. So these x's are equal to 7 pi over 6 in the third quadrant and 11 pi over 6 in the fourth quadrant. So my final answers here are at pi over 2 in order 7 pi over 6, then at 3 pi over 2, then at 11 pi over 6. Sample 15 says solve sine of x cosine of x equals 1/2. For x's between 0 and 2 pi, use the double angle formula. This seems kind of stumped to me, but let's go ahead. Let's multiply both sides by 2 and set this equal to 1. So if we multiply all of this by 2, we get 2 sine of x cosine of x equals 1. Well, 2 sine of u cosine of u equals the sine of 2u. I've got one of my double angle formulas down here. I can't use any of these other ones for cosine, so let's go ahead and use the fact that 2 sine of u cosine of u equals the sine of 2u. So now I have the sine of 2x equals 1. Well, where does the sine of x equal 1 on my unit circle but up here at pi over 2? So using my inverse sine, now I know that 2x is equal to pi over 2, and that's going to happen every 2 pi n, every loop around the unit circle. So plus 2 pi n. I need to solve for x, so I'm going to multiply all this by 1/2, and I get x equals pi over 4 plus pi n. I'm asked just for 0 to 2 pi, so x is going to be at pi over 4 and 5 pi over 4. Sample 16 says solve the equation cosine of 2x plus 3 sine of x minus 2 equals 0. I look at this and I see factoring. I kind of want to factor this, but I need everything in terms of either sine or cosine. Well, I've got this double angle here that's the cosine of 2x. Maybe I can find a double angle formula that is written in terms of sine. So I've got the cosine of 2u, and it equals 1 minus 2 sine squared u. So I'm going to replace the cosine of 2x. I'm going to replace that with 1 minus 2 sine squared u. So I get 1 minus 2 sine squared x plus 3 sine x minus 2 equals 0. I'm going to combine my 1 and negative 2, and I'll get negative 2 sine squared x plus 3 sine of x minus 1 equals 0. I'll multiply everything by negative 1, so I get 2 sine squared x minus 3 sine of x plus 1 equals 0. And now let's see if I can factor that. So that becomes 2 sine of x and sine of x, because that's 2 sine squared x. Factors of 1 are just going to be 1 and 1, and they both have to be negative. So now I factor that, and minus sine x minus 2 sine x is minus 3 sine x. It foils back, so that does work. Now I'll set each one of these factors equal to 0 and solve for x. So the left-hand factor becomes sine of x equals 1/2, and the right factor becomes sine of x equals 1. So I think about my unit circle, and where is sine equal to 1/2 but at pi over 6 and 5 pi over 6? So, and where is sine equal to 1 but at pi over 2? And we're asked for just 0 to 2 pi, so those are our answers for x. Sample 17, solve the equation sine x minus cosine x equals 1 between 0 and 2 pi. So I don't have to worry about multiple revolutions. This is one we are going to square both sides. So how do you know that? Well, I kind of told you that. So if we square both sides, we get sine x minus cosine x quantity squared equals 1 squared. So if we know our multiplication formula here, we'll get sine squared x minus 2 sine x cosine x plus cosine squared x equals 1. A squared minus 2 times a times b plus b squared, and that equals 1. Well, this 2 sine x cosine x looks like one of my double angle formulas. And sine squared x and cosine squared x, those also can combine. So I'm going to replace 2 sine x cosine x with sine of 2x. So I have sine squared x minus sine of 2x plus cosine squared x equals 1. Well, sine squared x plus cosine squared equals 1. These two are Pythagorean identity. So now I have 1 minus sine of 2x equals 1. I can subtract 1 from both sides. I can divide by negative 1, and I get sine of 2x equals 0. I think about my unit circle, where is sine equal to 0, but at 0 and pi. So again, sine is 0 at 0 and pi. So the sine of 2x equals 0, so 2x equals 0 plus 2 pi n every revolution, and 2x equals pi plus 2 pi n. If I multiply both sides by 1/2, I get x equals pi n, and I get x equals pi over 2 plus pi n. I'm only asked for the interval between 0 and 2 pi, so we get pi over 2 and pi for our two values for x. In example 18, let's solve the equation sine of x minus the square root of 3 cosine of x equals 1 between 0 and 2 pi. Let's go ahead and move this minus square root of 3 cosine of x over to the other side. So that will give us just the sine of x equals 1 plus square root of 3 cosine of x. When we square both sides, we get sine squared x, and foiling out using our pattern, we get 1 plus 2 square root of 3 cosine x plus 3 cosine squared x. Now we'd like to have both sine squared and cosine squared. Well, we'd like one of these to become either all sine squared or all cosine squared. So I'm going to take the sine squared x and I'm going to use my Pythagorean identity and I'm going to replace that, and I'm going to make that 1 minus cosine squared x equals 1 plus 2 square root of 3 cosine x plus 3 cosine squared x. So now I have all cosine squared x's, and all cosine x's, which is really good. Okay, I'll do some simplifying. It looks like the ones on either side are gonna cancel out. I'll add cosine squared x to the other side, and so I will get 0 equals 4 cosine squared x plus 2 square root of 3 cosine x. At this point, I have a common factor of cosine x that I can take out, giving me 0. I'm taking out my cosine of x, and I'm left with 4 cosine of x plus 2 square root of 3. And that, of course, is equal to 0. So now I have my two factors. I can set each factor equal to 0. So I have cosine x equals 0 and 4 cosine x plus 2 square root of 3 equals 0. I subtract 2 square root of 3 from both sides, divide by 4, and here I get cosine equals negative square root of 3 over 2, and cosine of x equals 0. So cosine of x equals 0 occurs at two places. It occurs at x equals pi over 2 and 3 pi over 2. And cosine of x equals negative square root of 3 over 2. That's going to happen only in quadrants 2 and 3. So that's going to occur at x equals 5 pi over 6 and 7 pi over 6. At this point, we have to check for extraneous roots. So we substitute these values into our original equation, and we find that 5 pi over 6 and 3 pi over 2 are extraneous. So we get x equals pi over 2 and x equals 7 pi over 6. Those are the values that we could put into this function for x, and that will equal 1. And that wraps up solving trig equations. A lot of work here, and we'll get some practice with this when I see you in class.